That could be why.
It's still going. All right, cool. Cool.
Go again. Do you like close it down and then restart, or you just
No, we'll just go again. These things happen.
go again?
So, can't rely on the systems these days.
Oh no. And technology. Who'd have it?
Anyway, so we're going to start again. Unfortunately, we're having some microphone issues, but we are back, and hopefully you can hear us all okay. So we're back with Stormwater School Live, and unfortunately we had to move it to the Wednesday today, as unfortunately we couldn't do it yesterday. We had a whole company meeting, and we were very fortunate enough to have an Olympic athlete, a gold-winning Olympic athlete, with us to talk about his journey to winning gold and the lessons he learned and how it can be put into businesses, the kind of mirrors of success between sport and business. And could you guys guess who the Olympic athlete was? We'll get you guys to comment in the comment section below of who you think it was. Here is a clue. If you are an avid reader of our Water Matters newsletter, we have mentioned his name in the past. So if you remember kind of what we talked about with this guy, you'll probably have a good guess of who it might be. But nevertheless, we're sorry to ruin your weekly routines and have to move the Stormwater School onto the Wednesday instead of the Tuesday, but we'll be back next week on a Tuesday. And we can confirm that will take place. But today's Stormwater School is all about how we size stormwater attenuation tanks and what we need to consider. And to answer those questions, we've got Danielle in the hot seat with us this week, who's very, very excited to join us and has been wanting to do this for a long time.
I've just got deja vu, Callum. But yes, I'm very excited to be here. So I am Danielle, and I am part of the Stormwater team. And just going on to your question, Callum, should we just run straight into it?
Let's, head straight into it.
Okay, cool. So when sizing, well, in order to know how to size an attenuation or a soakaway system, most of the time before it gets to us, the drainage layout drawing and volumes will already have been established. So most of the time when we're pricing up jobs, we've already got that information. But what we can offer is something called storm flow calcs. So if you haven't got to that stage of the project yet, we can definitely help you out with sizing and establish what size system is needed. And in order to do that, you'll either have an attenuation tank or a soakaway. So to see which one is needed, we mainly need to know the location, and that is to calculate the annual rainfall. And then we also need to know the catchment area, so any roof areas, hard surface areas, basically wherever the tank's going to be collecting from. And then even if it's an attenuation or a soakaway, we need to know the storm event period. So whether a storm event is going to be 1 in 30 years or 1 in 100 years, we take that into account when establishing the size. Now, if a soakaway is needed, what we need, which might have been done by the time it gets to us, it might not, but we need to know the permeability of the soil. So this is how quickly the ground soaks away. So if you've done that, then you might have done some trial pits. You basically dig a hole and see how quickly it fills to actually see whether a soakaway is going to work. And if a soakaway is going to work, then we'll have that infiltration rate. But if it doesn't soak away, then what will be needed is an attenuation tank. So the extra information that's needed for an attenuation tank is something called a flow rate. And that's basically the litres per second that it's allowed to go back out into the drains at. So you'll be able to get that from your local authority. They'll be able to provide that information. And then once you can get that over to us, we can do these storm flow calcs and establish what volume's required and then put our tank size to it and price up the job. So yeah, if you need that doing, then we could do that.
Perfect. I think there's a very good overview of how we size stormwater systems. And you mentioned there, kind of the key thing is, well, they need to know what they either need an attenuation or soakaway. And the first thing they need to do is make sure they have a percolation test done with the results to hand to ensure that we not only size the right system, but the right system is chosen to be sized.
Yeah, exactly that. And at this point, they would have been told that they need to put some form of tank underground in to collect for where the rain would usually fall. So I imagine the engineer or the local authority would be able to help you with the extra information if you need it.
And when it comes to kind of working out the flow rate, that would just be the case for attenuation.
Yes, yeah. So flow rate just for the attenuation, and you'd only need infiltration tests for a soakaway, because with a soakaway, that's just wrapped in a permeable textile, so the water can soak through, whereas an attenuation tank will have a flow control at the end, and it's wrapped in an impermeable membrane and a permeable membrane and a permeable flammable textile. So basically it's watertight, so it's heat welded, and that will actually hold the water and then release it back out at a certain rate.
And once you've got the flow rate, and you mentioned there about having a flow control at the end, with manufacturers, you would need to then tell them what the flow rate would need to be so they can make the flow control needed for the project.
Yeah, so usually that will be confirmed by the local authorities on what release rate it's allowed back out into the mains at, and that then establishes the volume, because it depends how much the tank can actually hold and then release back out. So
before we talked about kind of storm event periods, you said either 1 in 30 or 1 in 100.
Yeah.
So depending on kind of what that storm return period could be, is how big the tank might become extra.
Yeah, so 1 in 30. So if there's going to be a rain, so obviously we don't get flooding all the time, but with climate change and everything happening, then we have to allow for a worst case scenario. So the tank actually isn't always full. It's just for that storm event should it happen, to prevent flooding. So 1 in 30 years or 1 in 100 years will vary the tank size needed.
And I mean, we've seen all the storms this year, basically at the start of the year. I think we had Storm Eunice, Storm D and F, all in the
Storm
same.
Everyone.
Yeah, they are named after names, but I can't remember the names to save my life.
Yeah.
But they all happen within a week, and they are storm turn or storm period events that are between that 30 and 100 ratio.
Yeah.
So those sort of systems are designed for the capabilities of withholding the stormwater from those events.
Yeah, exactly that.
Perfect. I think that's a very in-depth overview of how we size attenuation tanks and all the things that need to be considered. So now that we've covered the main topic today, it's time to go into our project highlight for this week and with stormwater, because our team are smashing out installs all the time and have completed many projects throughout the week. We've got a surplus of projects to show you today. So I think the first one we have up to show you guys is it Oakview?
Oakwood School.
Oakwood School, sorry.
Yeah, so we've got Oakwood School, which is actually one of my projects that we did with Stevens Construction and Keyline. It's an expansion to an existing school in Surrey. And this one, it was a nice little job. There was 2 small tanks, and we put forward our EcoBlock Max. And I think it totaled about 46 cube for the 2 tanks combined. And it was a lovely job. We worked very closely with the engineer. The engineer is Fairhurst, and basically one of the tanks, I remember, I think it was the first tank, the spec wasn't, they needed to achieve a heavier loading basically. So we worked closely with the engineer, and actually the dimensions of our crate allowed us to go slightly shallower, which increased the amount of cover. So by increasing the amount of cover, we were able to get the heavier loading that they were needed. So all in all, we worked closely with everyone, and it was a really nice little job that we got installed in March. So
perfect. And then the next one we have, I believe, is Derby Road.
Yeah, so Derby Road in Nottingham is just a new development in Nottingham. I think it was by a river. This is one of Deb's projects, who's in the stormwater team. And I remember her saying that this was quite a complex one. So we worked quite closely with site to make sure everything ran smoothly. With this one, it was quite a deep tank. There's also 3 internal corners. So in addition to the 3 internal corners, which can take a bit more time to install, just because of how they're welded, there was also a lot of sheet piling, which makes it a bit more difficult to install. But I know that we worked very closely with everyone on site to make sure that everything ran as smoothly as possible. So I think this one was about 370 cube, and this was our EcoBlock Max as well. And I know that this was just one tank, so 370 cube. And on that, as some of you may know, with how our crates and how our EcoBlock is, one of the main benefits is how much that you can get on a lorry. So in comparison to a solid crate, 370 cube, you're probably looking at about 4 loads plus the material. So the M&G, which we call the membrane and textile surround, which is what's needed to go around the tank in addition to the crates. It was only one 13.6 meter, so 1 Arctic load and then a half load from us. So that helps site with the space, the restrictions on space anyway. It meant that there was less to transport into the excavation, which was difficult anyway, and less to store on site, and also less to offload. So another great project.
Because that is a very interesting point, because you can kind of see in the background of the image, you've got just kind of the apartments, the high rise, so you can tell it's going to be within the inner city. And being able to get a 300 odd cube tank in just 1.5 loads compared to 4 loads makes life on site
Yeah,
a whole lot
of a
easier
difference.
and takes up a lot less storage space, where it does seem
Yeah.
very compacted due to the kind of the space constraints obviously being in
Yeah.
quite an inner city area.
And as you know, there's a lot of works going on at the moment. So when it is in the city, it definitely helps on that space. So something to consider.
Perfect. And the next one we have up, I believe, is 2 tanks installed at Lansdowne Road.
Yeah. So Lansdowne Road is a new housing development in Carlisle. This is one of Cheryl's jobs. Cheryl's based up in Glasgow. And this was 2 lovely tanks, I think totaling about 300 cube. We work very closely with JDP on this one and Citadel Homes. And this one, we actually used our EcoBlock Lite. And I believe from speaking to Cheryl, we won this one mainly down to price. But with this, it also had the requirement for inspection. So another benefit to using our crates with the Lite, it meant that we could offer a lighter duty option, which is cost effective, but also include that run of inspect that's needed with integrated inspection chambers. So they had access within that tank, but it meant overall the solution was a lot more cost effective. So we could be competitive on the price. And also actually Cheryl had mentioned on this one, which I think is a really good example of what Graph are doing well at the moment with our teamwork, is there was some last minute changes to one of the tanks. We had to go a bit deeper to reduce the tank size just because of the space and stuff around it. So what we actually did was manage to work out what extra materials were required and get that sent to site really quickly so that we could get install completed in the allotted time that we'd allowed for, which meant no extra charges or anything. So that was also a really good bonus with working with everyone on site closely. So another lovely job for March.
Perfect. And I think that's all 3 jobs that we wanted to show you guys in the project recap. And there's some more photos on your screen now.
Yeah, I think it's actually also, sorry, just thinking about it, worth mentioning with the EcoBlock Lite, this one actually was 300 cube for 2 tanks. And with our EcoBlock Lite, you can get about 500, just over 500 cube on 1 lorry. So the total deliveries that went to this new housing development was just 1 Arctic load. So that had all the crates and also the membrane and textile surround on. So again, saving space and saving time transporting into the excavation. So also an added bonus for that one.
And not only so, it's like, or with that, the organisation of, with that, you'd be looking at potentially 5.5 lorries for single piece crates to transport all of that. Whereas with the EcoBlock Lite, like just you said, it was just on the one.
Yeah, and especially with transport costs and petrol prices at the moment, it's definitely another benefit to use in our products.
Perfect. And now it's time to move on to the Q&A section for today's Stormwater School. So we should have some of them fired up on the screen soon.
Everything I've been waiting for. Hopefully nothing too difficult.
Yeah, just need to switch the HDMI on the splitters just because they're not appearing on the screen, sorry. So
just bear with us, we're having some more technical difficulties.
It's not that one.
Do you want me to, I know one of the questions that we've been asked recently, if that helps, Callum?
Yes.
Yeah. So recently, one of the frequently asked questions that has been coming up is what is deflection? And deflection is basically a short-term deformity on crates when it's subject to a vehicle load on the ground above. All good?
Yes, all good. Sorry, we had a slight technical glitch. That was my fault. Sorry, I should have made sure the HDMI was in the right connection point heading into this, but we learned from it. Anyway, so
welcome
like you're saying, yes, the first question we had in is what is deflection and what happens during it?
Yes. So, sorry, I just briefly started. What is deflection? So deflection is a short-term deformation on crates when they're subjected to a vehicle loading on the ground above, which basically means every time a vehicle, so a lorry or a car, goes over the tank, the load that goes over, the wheel load is basically a concentrated load on the tank, which can cause it to deflect, so dip. So where you mainly get this is when we're looking at minimal cover. So a lot of the time, a minimum cover will be the minimum cover because this is where it would usually fail. It has to be below a certain figure. So we produce calcs in accordance with something called Syria C680, which is just a set of SUDS guidelines. And you have to keep it below this certain figure to make sure that the ground doesn't dip or defect, which is more of an issue with tarmac surfaces, hard surfaces, because obviously if they start to dip and slope, you have all sorts of issues. Whereas if it was a grassed area, it's not as much of an issue. But what we do is when we have the drawings, we'd look at the cover level and make sure that they're getting that cover needed for the loading, because that's where it would be an issue, is when you haven't got enough cover and then you get that load from the tank, which can cause the crates to dip pretty much.
Perfect. That answers that one. And the next question we have coming in. Can we install a perforated pipe with gravel surround in our tanks?
Yes. So a good question. This actually isn't something that we offer as standard, but in short, yes, it can be done. The things that we would look at is if we had to put forward this alternative or this option, is where the pipe is situated. Because when it comes to install, ideally, if it was going to be anywhere in the tank, if it's in the middle, the pipe and stone runs along the middle of the tank, you have the pressure from the crates either side and also the backfill, which keep the pipe and stone in place when you're wrapping up the tank. Whereas if it was to be situated towards the edge of a tank, that's when you haven't got that pressure coming in from either side. So there can be delays on install if anything were to happen, if it's not keeping it in place. But the best thing to do is send us over the drainage drawings and we can then have a look to see what we'd put forward and what the best solution is and go from there. But in short term, yes, it can be done.
Perfect. That answers that one. And on the next question we have coming in. Can geocellular tanks be constructed with internal corners, and how flexible are tanks constructed using geocellular crates?
So yes, you can have internal corners. It is something that we try to avoid where possible. So again, if we have the drainage drawings, we will always try and look whether we can go deeper to avoid them, but they can be done. It just creates weaker points. So if they can be avoided, then it's best to. But with our heat welded engineers, they can still make sure that it is heat welded and watertight. In terms of how flexible are tanks constructed using geocellular crates, I mean, you can pretty much have any design. Obviously, the regular shapes are a lot easier for the contractors to excavate because there's nothing worse when you have different shaped tanks with loads of internal corners. But we understand sometimes it has to be done with all the new works that are going on, especially when they're in crowded areas. You have to avoid certain things and pile caps. So when that happens, it's kind of, you don't have any other option. So we'll always try and put forward the best design, but they obviously have dimensions that you have to stick to. So you can't cut crates or anything. So we'll always put forward an alternative to what's been specified. But there is kind of no limit. It's just whether we can make it a better solution or not, pretty much.
Perfect.
Yeah.
I believe that answers that question. Thanks for sending that one in. And then I think we have another one coming up. Why would you use gravel and pipe through a geocellular tank?
So a great question. We actually don't do this as standard, as we're quite lucky that we have inspectable crates that can run through as an alternative to this. But there might be some systems that need this gravel and pipe. So for example, our crates are a lot more open, so they don't get silted up. So if you have some people that have the crates that aren't as open, so they might get a build-up of dirt and stuff coming in, which can block them up. So it kind of defeats the object of them. They'll have to have this pipe and stone so that the water's going in and then the dirt can't get in the rest of the tank. Is pretty much the main reason. Obviously, if they need to inspect that pipe, but there's lots of different alternatives to using this. I think it's a method that some engineers are more familiar with, whereas we're still, I mean, we've been in the market for over 10 years, but the inspection run is something that we still push rather than this option, just because it's a lot easier to install. But yeah, so that's pretty much why you'd perhaps use it if you if certain the makeup of crates weren't as open, so you need that pipe and stone for it to operate efficiently. If you wanted to inspect that pipe. So yeah, they're kind of the main few reasons.
Perfect. And the next question we have coming in, how do we provide inspection as standard in our tanks?
So if, I'm assuming this means if the tank needs to be inspectable.
Yes.
Yeah. So we have a few different crate options. So our go-to would be either our EcoBlock Max or our EcoBlock Lite, both of which aren't inspectable. So what we would then do is we have our EcoBlock Flex Inspect, which you can inspect. It just allows a different setup of the crates where you can either get a jet or a camera through. And an added bonus to our EcoBlock Flex Inspect and also our EcoBlock is you can have internal inspection shafts, so what we call vario shafts, which basically is included in the volume. So you can have internal chambers where you can get access into the system without having any need for an external manhole, which helps to reduce the amount of connections and stuff into the tank. So you're keeping it all as one and also still including it as part of the volume.
Perfect. I think that answers that. And I think that's all the questions that have come in during today's session. So once again, thank you for taking the time out of your day to join us on the Stormwater School Live. We know you thoroughly enjoy these sessions, and we do too. We love sharing all of our knowledge about stormwater with you guys. So once again, thank you for taking the time, for watching, and allowing us to educate you on all things stormwater. And thank you for Danielle for your debut appearance on the Stormwater School. You did very, very well.
Thank you very much for having me. I look forward to the next one.
I can tell you do. Anyway, thank you very much for tuning in again, and we'll see you next Tuesday.